Hey guys, so what we're going to do today is we're going to start looking at how to solve quadratic equations by using different methods other than factoring. And some of you may have been thinking about like what happens if we can't factor it? How can we solve these possible equations? Because all equations in math are pretty much solvable. So that's what we're going to take a look at today. So today you're either going to need the packet that was posted on the Google Classroom or a piece of paper or a couple of pieces of paper to take notes, a pen and a calculator. And I'm going to start telling you when you need to take the notes just because I'm going to introduce it to you a little bit, just kind of give you an explanation of why we're doing what we're doing. But it's really important once we start taking the notes that you become an active participant or else you're going to be lost in this process. It's a very step-by-step process. And if you don't get those down and follow along, it's going to be very challenging. All right. So what we're going to do is we're going to be learning two other methods for solving the quadratic equation. One of them is called completing the square, which we're going to look at today, and the other is the quadratic formula. So we are going to delve deep into those two. Some of you might like using one over the other. You can use whichever one you want, or factoring when solving a quadratic. All three of them will work. These two will work for all quadratics. However, factoring only works for factorable quadratics. So you can solve now using whatever method you want. We generally use one of these methods when a quadratic isn't factorable. Like I said before, people might use it all the time now. It doesn't matter what you use. It's just whatever you're comfortable with. But we use these when equations have solutions that are what we call irrational. Irrational just means that your solutions are going to have either a non-terminating, non-repeating decimal, or in the future, something called imaginary solutions as well. And we're going to talk about it in the future. It's something called roots as well. So, and our answers before have been coming out to integers, whole numbers, fractions, nice decimals, but these today are probably going to come out to irrational solutions. All right, so today we're going to complete the square, and I compare it to long division because it's a process with many steps that sometimes takes a while to get down, but once you do, it's really simple, and you might actually love it. So here's where we're going to start our notes. I want you to start taking these down. This is just an intro, just again repeating, going through the steps on how to attack any problem when solving a quadratic. So we're going to start taking the notes down here. And if you have a packet, copy it here. So your first thing you always want to check to see is if the quadratic is factorable, because that's the easiest way to do it. So we put our 1 in front, we multiply it to the -7, we get down -7, we copy that, we get our factors of -7, -1, 7, 1, -7, and we see which one adds to -4, which is the middle term. But as you notice, the only two answers are 6 and -6. So there is no way to factor this quadratic. So that's why today we are going to learn something called completing the square, where we can solve this quadratic now, meaning get your answers for x that make this equation true, by using another method. All right, so how do we complete this square? Well, first of all, in order to complete this square, your a has to be equal to 1. So let's just review what a is. A is the number in front of x squared, b is the number in front of x, and c is our constant. We are going to be referring to all three of those today as well. But for today's lesson, we are going to have a equal to 1. In the future, I'll show you what to do when it's not equal to 1. In order to solve a quadratic also, you're not going to be setting it equal to 0. We're actually going to be isolating the x term today. So that's going to be fun. All right, here are the steps to completing the square. It's on the packet. I am going to go through them step by step. I'm not going to read them to you right now because it's probably going to be very confusing as I read them to you before we actually start doing it. All right, so let's get started. So it says here, together we're going to solve x squared minus 4x minus 7 equals 0 by completing the square. So our step 1, like on our steps, it says isolate the x terms, which means move the -7, and then we're going to add a square to hold its spot. So to move the -7, we're going to add 7 to both sides. And what's going to happen is we're going to keep that spot open where the 7 was, and we're going to put the 7 onto the other side, just like so. Pause the video, make sure you get this down. Now we're going to add a square to both sides, and we're going to be adding because eventually we're going to be putting in numbers there, and they're always going to be positive. Okay, so pause the video, make sure you get that down. Now we're going on to step 2. Step 2 says find b, take half of it, then square it. So remember, b is the number in front of our x term. So b is -4, so we're going to find b. -4, we're going to have it, which means divide it by 2, and we get -2. And then we're going to take -2 and square it, and we're going to get +4. So when we square the number, we're going to put that number in the square. That -2 that's in the parentheses that we got when we have it is going to be an important number as well. So everybody pause the video, make sure you get this down. Now number 3, we're going to add that number 4. We're going to fill it into the square on both sides, just like so. Make sure you get that down. Okay, and now we're just going to clean up the equation, just make it look nicer. So I'm just going to rewrite it. I'm going to keep it as x squared minus 4x plus 4. And now on the right-hand side, I'm going to add my 7 and 4 and get 11. Now what we just made on the left-hand side is something called a perfect square trinomial. And it's factorable. That's what we were doing. We're purposely making it factorable. So I want you to pause the video and factor x squared minus 4x plus 4 and see if you get the same answer as I did. You should have gotten x minus 2 times x minus 2. And that's the way it's always going to work out. Do you notice that that -2 that we got when we halved our number is the number that goes in our factors? And they're all related. It's purposely working out this way. All right. So now what we did, we factored our step. And now we're going to write it as a perfect square, meaning we're going to just write x minus 2 times x minus 2 is really x minus 2 squared. And we keep our 11 as we're going down. All right, so pause the video, make sure you get this down. Step 5 is we're going to take the square root of each side. That's going to help us solve for x. So when we take the square root of both sides, we're going to pull out the x minus 2 from the little squared term because we're undoing a square. We'll bring our equal sign, but now we just have to remember when we square root a number, now we have 2 possible answers, a plus and minus answer. So that plus and minus sign has to come out in front of the 11, a square root of 11. Now our goal is going to be solve for x. We need to get that x by itself where that -2 is. So that's step 6. We're going to write and solve the 2 equations. So we're going to add 2 to both sides. But the key here is we're going to cross off the 2. We're going to bring down our x, but that 2 is going to come down in front. It's not going to go behind it. And then we bring down the plus or minus radical 11 there. Okay, just want to make sure you can see it. So that's how our answer is going to look. That whole number that we added over goes in front, and then the plus and minus radical 11 goes after it. Now the next step is we have to separate it. Remember, in our growth and decay formula, when we have plus or minus answer, we have 2 separate answers here that we kind of made into one to make it easier to solve. So what we're going to do is we're going to separate it. So I have x equals 2 plus 11 radical 11, or I have x equals 2 minus radical 11. So what you're going to do now, sometimes they're going to ask you to see if you want your answer rounded to a specific decimal. So that's where you might have to put it into your calculator to get that expression. I just want to show you both ways. So if you put 2 plus radical 11, you can keep it in radical form, or you could put it as a decimal. Put 2 plus a radical 11 in your calculator, press enter, you should get 5.32. If rounded to the nearest hundredth. I'm just using hundredth for right now. Same thing happens for the next one. If you put 2 minus radical 11 in your calculator, press enter, you should get negative 1.32. So we just solved this equation for x using completing the square. So what you're going to do is you're going to try these on your own and check your answers with the answer key provided on the Google Classroom. Excuse me. If you got any wrong, watch the second video where I guide you through each of the 3 examples. What I'm going to then ask you to do is choose 4 examples from the classwork problems and send me a picture of all the work you completed. Showing only the answers is going to result in a 0. I know many of you have different avenues of getting answers. That's not the point. The point is for me to see your work. So remember, the work can be done on any sort of paper. If you don't have a printer or you don't have Cami, it's not working for you, you could write it out on a piece of loose leaf and send me pictures from there. Just make sure your name is on the top and you number it. Okay? Thanks, guys, and good luck.